Today we're not only going to see how it works, but we're also going to lend a hand in the construction of a solar power plant. Let's check it out. We're going to São Gonçalo do Borgeia in southern Piauí. As you may expect, it's among the sunniest locations in Brazil. Ideal for a solar plant. Depart from Guarulhos Airport in São Paulo to get there. Fly to Brasilia, where we change planes and land in Barreiras in the far west of Bahia. Then we take a car, drive for 3 hours to Corrente, which is already in Piauí, where we sleep in a hotel. And the next day, we drive another 40 kilometers to reach the São Gonçalo Solar Park by Enel Green Power. It is the largest solar park in Brazil. Solar energy is one of the cleanest and completely renewable energies. This means that we can use this resource from nature and it will not run out. It's very different from oil, for example, which not only has an end, but also generates a lot of carbon dioxide. Here, on the contrary, we avoid the generation of carbon dioxide. It's 8 in the morning. I'm going to put on a GoPro, make a time lapse, and we will see the movement of the panels throughout the day. We'll come back here around 6 in the evening. It ended up looking like an alien nest. No telling what passersby will think. Before seeing the plant in operation, let's take a look at how a solar plant is constructed. The first step to install the plant is to have a clean and flat land, just like you're seeing here. The first piece that will be installed is this stake that will support the entire structure of the solar panels. It is 4 meters long, and half of it has to be driven into the ground. This is done by a pile driver that is operated by remote control. Fast. A metal base will be installed on top of each stake. This task is done by women, who here in São Gonçalo make up 15% of the workforce, which is much higher than the average in this type of project. A handler, which is this huge red tractor, will install a 230 kilogram square axle on the stakes. Then some crossbars will still be placed on top of the axle. And what we're gonna have in the end is a structure similar to a fishbone with a spinal column and several ribs. This is what will support the photovoltaic panels, but this place is big, very big. It's gigantic. Over there it's just beginning, but I know you're curious to see the panels. There's a crew installing them in the back. Let's take a look. The park will have 2,200,000 panels. The installation process must be simple to avoid trouble. Let's attempt it, although it's a bit heavy, man. And now, come this way.
No, now it's gonna turn.
Okay.
You hold the tool to go up.
Okay, I'm holding it. Now it fits here, right? Now it's done. Man, it's hard to fit. It's done. It's done. I found it really straightforward, but there are many hidden details. Fit. And the key stays here. It's already here. I think I did okay, just okay. After 1,800,000 plates, I think it's good. Get up, take it off.
It still needs to be raised a bit more.
Now it's done. How many of these do you put up each day? 280, 300. The plates are shipped from China in this cardboard box. There are 32 plates per box. And since it doesn't have a frame, it's all directly on the glass. It needs to have very good protection so that one plate doesn't hit another. There's also a tattletale sensor. Quite interesting in this box. This sticker has 2 white tubes, and if someone transports the box in a very violent way, hits it, they will turn red, and this indicates that there is something broken inside. It would be nice if we could have this in the suitcase at the airport. Let's take it out of the box to see if it turns red. If you're paying close attention to the video, you should have noticed that the front and back of the plate are practically identical. The only difference is that on the back, we're going to have an outlet here at the end to connect the power cable. This means that this plate generates power from both sides. Light is coming from the sunlit side as well as from the other side where light is reflected off the ground and the plate. Look there. You will have higher yield, allowing you to generate more energy on the same land. Such a plate lasts an estimated 25 years, far longer than one that only works on one side. And one of Enel's major concerns is that these plates are recycled afterwards. So the idea is that 25 years later, they return to the factory, are disassembled, and the glass and all parts are reused. You must have noticed that some stakes have a red equipment on top. This here is a tracker. It has a motor, a reduction box, which makes the motor movement very slow, but also very strong. And a black box, which controls the motor and all this structure. This is used to move the axis and tilt the plates. And why would we want to tilt the plates? If it were a house roof, for example, they would be fixed. This is important because the ideal position of the plate, it's always 90 degrees in relation to the light that's coming from the sun. So let's suppose the sun is here. The light is coming at 90 degrees on top of the plate, but the sun moves. And the ideal is that the plate moves to follow the movement of the sun. This means that a fixed plate, it will always be less efficient than a plate that can move, like this one here. This inclination will be a very slow movement happening over an entire day. That's what we're trying to see in the time lapse if everything goes right. It will be good. But we can install equipment here to speed up the process and see the results faster. Even at high speed, it's slow. Consider the structure's weight. How many tracker boards are there? 90 boards for the tracker. They told me here that when the entire structure is ready, each tracker moves almost 4 tons. I want to get closer to the boards, but to cross this rope here, I already need to wear a flame-resistant shirt. Each of these boards generates 385 watts if the sun is at its peak at maximum sunlight. That means you would need about 3 boards to iron your clothes, for example. I got a piece of board that had an accident, and we can clearly see the layers of the sandwich. First, there will be a piece of glass. After the glass comes an insulator, which is a plastic. It's a polymer. Then the silicon, which is this black part that we can see here, where it generates energy. In this case, we will have silicon on both sides, right? The layers repeat with the insulator and glass. Upon close inspection, silver stripes are visible. They are the tracks that will carry energy to this connector that is the output of the board. How does this thing manage to generate energy with the sun's radiation? On the board, there are 2 types of silicon, which are treated in a different way. In the first treatment, the silicon will end up with some extra electrons, and in the second treatment, it will end up with some fewer electrons. When the photons, which are particles of light, get here, they cause the electrons that are in the silicon that has extra electrons to move and go to the silicon that has fewer electrons. And if you remember well, electron movement is electric current, it's electrical energy. The energy generated by the panels will be transported under the earth by these cables. Each has a voltage of 1,500 volts. If you think this cable here is big, watch a little longer and you'll see a respectable cable. For every 16,000 panels, there will be an electrocenter, the white structure in the background. It contains 2 critical pieces of equipment. The first one is an inverter. boy, it wasn't just the plastic here. The first is the inverter, which is a device that transforms direct current energy, which comes from the panels in direct current. It's an energy similar to a battery that you have there to put in a flashlight, in which there is a positive pole and a negative pole, into alternating current in which the positive and negative poles keep inverting. And the second device is a transformer. The energy arrives at 1,500 volts and leaves here at 34,000 volts. From here, the energy is transported by a cable a little thicker than the one we just saw. As one goes next to the other, it needs a lot of insulation, a very thick layer of plastic, so the cable ends up being about 5 centimeters in diameter. Is this easy to bend? It won't bend, not even if hell freezes over. The last place the energy will pass through is this substation. Those 2 transformers over there are going to do that job. And they are more or less like a cell phone charger, just a little bit bigger. For safety reasons, we can't get close, but it's these 2 here. If solar energy is so clean, why don't we have many more plants like this one? Why haven't we already replaced all the plants that pollute more today?
So, a few years ago, solar panels, which are most of the objects we have in the plant, were very expensive and always imported. There wasn't competition like there is today. So this made the process expensive, and we had a lot of difficulty bringing these panels wherever they were from here to Brazil. Today, the number of competitors and manufacturers is growing rapidly and continues to rise daily.
It's almost 6 in the evening, and the panels that were facing east, which is where the sun rises, have now turned to the west, which is where the sun sets. This also means that our time lapse is already ending, and we can take our Easter egg from here. A lot of people asked if the panels can generate energy from the moonlight. They can't. In fact, if they could generate with moonlight, it could be called a lunar panel, right? The camera's at full battery, still running. Our power bank did the job. 1,023 photos for the upcoming time-lapse video. If you like it, be sure to give it a thumbs up below.